Welcome back to the Machine Learning Street Talk YouTube channel and podcast. Today, we're going to have a conversation with a cybersecurity professional. Andy Smith. I've been planning a conversation on ML DevOps for quite some time, and I recorded loads of footage with AWS, but it turns out that I've got about 5 hours worth of footage, and I need to approve that footage with AWS before I publish it. And the conversation I had with Andy, all about threat modeling and security for machine learning, I just felt like it was a great conversation and it stood on its own 2 feet. Anyway, I hope you enjoyed the conversation. Remember to like, comment, and subscribe. We love reading your comments, and we'll see you back next week. So, I am here with Andy Smith, a cybersecurity professional in the industry. Hello, Andy.
Hi, Tim. How's it going?
Very good indeed. Andy, we're making a show all about ML DevOps. And one of the things that exasperates me about ML DevOps is I think people haven't really seen it done at scale. And in the context of a large organization, I mean, in my opinion, ML DevOps is mostly process. And one of the most important processes is security. And in a large organization, how would an ML DevOps team engage with the cybersecurity folks?
I think it very much depends on the setup of an organization. In some organizations, the security function is a completely separate team, in which case there'll be some kind of defined interface for typically raising an engagement with those security folks to get their input on a certain activity. In other organizations, the expectation is that developers who are creating the system will have a very, very strong understanding of the security factors that affect their particular solution. The reality is, it's usually a bit of both, in that we would hope that our developers have a pretty good understanding of the security of the systems they're building, but there might be certain specialist areas where they need a security pro to come in and to give them some prompts in the right direction.
That's awesome. It feels a bit overwhelming to me because what makes DevOps so difficult, especially in machine learning, is the multidisciplinary teams and all of the different systems you're touching. So on one end of the system, you're ingesting data from a data platform, and large companies typically have a data platform on its own. They have a monolithic data platform, probably one on every single cloud provider, and they have data engineering kind of platform team, and they have lots of data management and security and stuff. And then you've got your data engineering pipelines, and you've got your ML DevOps systems, and then on the other end you've got how you productionize the models and so on. So it just seems like an entire universe of complexity. So where do you even start?
Yeah, absolutely. Systems are massively complicated, and even more so when we're talking about AI and ML systems. So one of the approaches that we typically recommend from a cybersecurity point of view to help deal with some of that complexity and to help identify where there might be cybersecurity flaws in a system is a process called threat modeling. And this is something that we all do on a daily basis as part of our normal lives. When we're crossing the road, we threat model the situation to work out whether we're going to get run over or not. But we humans, we're not necessarily always particularly great at doing that in an accurate and pragmatic way. For example, a lot of people have a fear of flying because they think, oh no, the plane's going to crash and I'm going to die. Whereas the statistics show that you're far more likely to be seriously injured in a car accident than an aircraft accident. So we know humans are not necessarily great at judging risk. So to help that, usually a threat modeling process will try and structure people's thinking around the cybersecurity threats of a system. So instead of chucking a bunch of developers in a room and saying, tell us about the security problems, go, the threat modeling frameworks will try and provide a much more structured methodology for thinking about where those flaws might appear. And where we have really, really complex systems, well, you could get stuck down in the weeds very quickly. So for an initial threat modeling exercise, maybe we force everyone to think at that 50,000 foot view of, okay, maybe let's segment an application into some really high level chunks of, say, when we're talking about, say, an ML pipeline system, maybe we've got a dev environment, we've got a production environment, and then we've got our users that are maybe sitting on the other end of the internet somewhere. And we'll draw trust boundaries between each of those big parts of a system, and then drill down for each of those trust boundaries, talk about the specific factors that might affect the cybersecurity of a system. Now, of course, there are definitely going to be other trust boundaries at a lower level in each of those main blocks, but at least by starting off with that top level view, we get a bit of an idea of the overall security of the system and some of the main threats, and then we can drill down into some of those other areas in more detail in subsequent sessions.
That's really interesting. I mean, the first thing I get from that is there is a degree of pragmatism, because you can't possibly take everything to the nth degree, because you would never make any progress. And I love this concept of risk management, because it's the same framework we actually use for AI ethics or for compliance and legals and stuff like that. It's about having stakeholders make an assessment about what the state of play is at a particular time. The other thing I wanted to get to is you spoke about these trust boundaries, and I suppose the way you engage with a team would depend on their level of maturity. So if I were to design an ML DevOps system, there would be certain principles that it would need to abide by. For example, ephemeral stateless architecture and using a lot of the cloud architecture design principles, like, for example, elastic autoscale. But one of the principal things is isolation. So I would have a separate dev and production environment. And a lot of this is about kind of saying, how do we contain a problem? So even if the dev environment got taken over by an adversary, how could we contain that? But this exercise that you're discussing would highlight those issues.
Yeah, absolutely. So the threat modeling process will try and identify the various sources of threats, which you can then push into a risk management process to decide what are you going to do about them. In some cases, the risk is very significant. We feel like it's highly likely that a particular threat will be exploited, and actually the impact could be quite high, so we should definitely do something about this. In other cases, maybe the risk is quite low, so therefore we simply accept that that's going to happen. So I know you and I have spoken about a number of specific threat scenarios for ML models previously. And on previous episodes of the show, Tim, you've spoken about adversarial examples. And that's an area which I think the conclusion of that episode was, yeah, it's a thing in the lab, but does it happen in real life? Not really. And so that may be a great case where a DevOps team decide, actually, no, we know that potentially our model might be affected by a adversarial example, but we are intentionally not going to do anything about it because actually we've got a much bigger problem elsewhere. Maybe we're not using multi-factor authentication for any of our access, and we believe that is going to be a much bigger threat to us.
I think that's fascinating, because it does come down to the fundamentals. I think a lot of people, when they read or when they talk about ML security, they have this rather fanciful view that the problem is going to be adversaries, perturbing image inputs to take over our systems, and actually it's a little bit more mundane than that. As you say, it's things like multi-factor authentication and security containers. The other thing is, the dream of DevOps is to kind of automate everything, but I think that's a myth. Actually, when you have a large organization and lots of different systems and people, it's all about process, and a lot of that is interactive. It's manual. So you might have teams that have to go to a site where they fill out a form in order to get some cloud architecture and so on. And when you do the threat modeling sessions, a lot of the threats that come up are around those kind of attack vectors, basically, where either inadvertently or maliciously people put the wrong thing in those forms and they subvert the process that we've designed.
Yeah, I think there's definitely a blend of intentional malicious activity that needs to be guarded against, and also like the fat finger syndrome, accidentally doing the wrong thing.
Yeah, the kind of threats that come up in practice are not what you would expect. Actually, some of them just come down to the kind of security fundamentals that you probably have dealt with for the last 15 years. A lot of it is maybe trust boundaries are the right way to describe this, but when you have people and systems and organizational boundaries and flows of information that transgresses these boundaries, that's almost where you have the potential for people to exploit your system. And in some sense, it doesn't matter that it's a machine learning. I mean, machine learning systems are more complicated, of course, but it seems to be going back to those security fundamentals.
Yeah, absolutely. There's nothing inherently about an ML system from a DevOps point of view that is really that different to any other system. There's still code that you need to protect, and if someone modifies that code, then they can change the operation of your system. There's still data that needs to be protected, maybe because otherwise, you will end up with regulatory issues if it's privacy related information, or maybe you just generally your business suffers if records that are meant to be accurate and modified, and all of these types of things is almost coming back to classic confidentiality, integrity, availability type problems that we've been looking at in cybersecurity for many years. I think there are some aspects of an ML system that introduce some unique security vulnerabilities. And we've spoken about these before, Tim. These are ones that can feel like they're slightly contrived. They're kind of like the quite academic type threats, things like adversarial examples. And whilst I would probably agree with the fact that these are going to be lower risk items in the grand scheme of things today, the question is, well, what are those threat vectors going to look like tomorrow? When we get further down the line, will those adversarial examples simply be remembered as a cool little trick that you used to be able to play with ML systems? Or is that actually turning into a genuine threat that we need to be very guarded against, and maybe doing a lot more than we are doing today?
Yeah, I think we shouldn't be dismissive. That was something that surprised me. So when we spoke to Florian Tremer and Nicholas Carlini from Google, they almost dismissed it. They just said that they haven't seen this in the wild at all. No, Florian Tremer wrote a paper about how folks were using it to disrupt ad blockers. So you now get these perceptual ad blockers, and there actually is a kind of a reason to disrupt the blockers there. So the advertisers will add some imperceptible noise to their ads to fool the blockers. So that was a great example. But they said they're not seeing it used in practice. But at the end of the day, if you have an adversary out there, then they will exploit. It's almost like if you've got a castle wall and there are weaknesses in the wall, then your adversaries will go straight to those weaknesses. If they're not doing it now, they will do it later. So I think the fact that no one's doing it in the wild at the moment isn't a reason not to take it seriously.
Absolutely. And I mean, an attacker will always try and go after the weakest part of a system. They've got time, they've got a limited amount of money, maybe. They want to maximize their opportunity for doing bad stuff. So, whilst again today, the more traditional threats of have you got the right kind of firewalling? Are you checking for SQL injection? Are you using MFA? All these classic things are certainly going to be big gaping holes in that nice castle perimeter today if they're missing. That's not to say that the more creative adversarial examples and other ML specific attack vectors are just non-existent. They certainly are
Yeah.
there. And I kind of maybe draw some parallels here with cryptography. So if you ask most cybersecurity people, they'll have a good understanding of cryptography in terms of, oh, you've maybe got symmetric and asymmetric algorithms. Oh, and you've got hashing versus encryption. Most security people will understand to a good level the foundations. But almost no one in security will be able to tell you exactly how does AES 256 work. What is the exact order of operations? And what are the specific threats, that would open that up to some kind of compromise?
Yeah.
So what we end up with is a bunch of people that know enough to do their jobs. So for example, I can tell you, you absolutely should not use the MD5 hash because it's terribly badly broken. Can I undertake a real life MD5 hash collision in the wild Hey, that's really, really tough to do. And I kind of see parallels, like I say, with some of these machine learning threats as well. I think it's important that those who are developing them understand enough of what they need to know today in order to defend their systems well, because there are going to be a very small number of very, very skilled people out there who do know a lot more and can actually implement some of these attacks in the world.
Yeah, I think that's fair. And that's actually a great example because we were talking a little bit about, well, maybe it's just coming back to security fundamentals, but there is something a bit different about ML DevOps. And it's what you just highlighted. It's the sense that there's a lot of fragmentation of knowledge, and you have these multidisciplinary teams, and the ML engineers and the software engineers probably don't know anything about the underlying algorithms, and probably the data scientists will even use even more complex models just to interpret the machine learning models. And again, you need to have expert knowledge to understand those interpretability methods. So you're in this situation now where we're having to rely on interfaces and testing, and we have this kind of sausage factory, and no one in that particular part of the sausage understands how the rest of the sausages are made. What could possibly go wrong? And with machine learning systems, as well as having the code, we now have data and models, and both of those things are kind of changing all the time. So it does make things significantly more complicated, I suppose.
Absolutely. And I guess that is one of the unique things of a machine learning system. We don't program a machine learning system by saying, if this, then that. We provide it with a bunch of data. It goes off and does its training process and produces something. And then, well, how do we verify that what has been produced is accurate and reliable? Well, we have to go through a lot of testing in order to gain confidence that it's going to operate fairly reliably in the wild. But if you compare that to a traditionally programmed system of a if this then that type statement, then that's something that's really provable. You can write very, very specific test cases for that, and you can have confidence, 100% confidence, that a system is going to work in a certain way. And for me, that's where one of the bigger challenges around machine learning security comes in and machine learning reliability comes in, is that element of unpredictability. The fact that you have input spaces that are so unimaginably vast that it's just not feasible to test every part of that input space. So there needs to be, I guess, a middle ground there in terms of how much testing do you do to have confidence to use an ML model in production. But then there's an element of, well, what is that model being used for? And are you happy for there to be a certain element of unpredictability in that? Or do you need to start including humans in the loop or that kind of thing? It comes back to this whole accountability for decision making. Are you happy that a machine will make a decision? Or do you want that machine simply to make a recommendation to a human who actually is then accountable for the decision?
Oh, you're getting onto something really interesting there, actually, which is how you design the overall process of how AI is used. But before that, you were talking about the size of the state space, and it's not necessarily even that, actually, because if you ask a software engineer to create the game of Tetris, how long would it take? They would say, I don't know, probably a few weeks. If you think about it, how many unique state spaces are there in Tetris? It's huge, right? Doesn't matter. The reason why software is better is because you can decompose it into smaller subproblems, and you can walk through the code with a debugger, and you can kind of understand in some sense what's going on. Whereas with machine learning, you've got no chance. But another example is a sorting algorithm. How many permutations of numbers are there? But we still trust that the sorting algorithm will generalize to every permutation of numbers that you could put in a list. And we write a few tests and we just trust that those tests are going to work. But machine learning is a completely different ballgame.
Absolutely, yeah. And like I say, it's that element of unpredictability that certainly from a security person's point of view is one of the concerns, because how if you can't say that a system is going to operate reliably, then yeah, that's obviously a concern, right? And I guess it depends on the nature of the system. If a system is being used for, I don't know, helping you decide what sandwich you want to order for lunch, that's probably not a big deal. If it's being used that could, in a way that could potentially be used for someone's life or death decisions, then you clearly want a lot more reliability there. And that's something that will obviously need to be taken into account when we start having some of these conversations about, okay, you've identified a threat to your system. What are we going to do about it? In cases for the sandwich ordering machine, we might say, actually, the impact is so small, even if it is going to happen, 1 in 5 times, the impact is so small, we don't care about it. Whereas for more serious decisions, clearly, we want very, very high reliability.
Absolutely. And something that I hope comes out of this conversation for folks that are listening is, I mean, Andy's a security person, but actually what he's talking about applies to explainability methods. It applies to legal and compliance and so on. Actually, that this mindset of risk management is thinking about the consequences of your system in production. What could go wrong and how could that affect us? And what do we need to do about it? And it's so much more than you might think of security as just being these kind of bad actors trying to exploit your system, but it's so much more than that. It's, we might need to give explanations of why we don't give credit to someone, otherwise the regulator could fine us lots of money and we could go out of business. It's actually all encompassing. But Andy, I wanted to get to this threat modeling exercise. So imagine I came to you with an ML DevOps architecture and we went through this modeling exercise. How would you go about doing that?
So I think the first thing would be to understand at a high level view what is the overall architecture of your solution. Normally this would be through a system diagram or a data flow diagram. And as I spoke about before, we probably want to start off at a fairly high level view and chunk a system up into reasonable sized areas, and then define on that where trust boundaries exist. So this is where one part of a system has to interface with another part of a system which it does not control, or there is a significant difference in trust level. So, for example, the difference between a dev system and a production system, there's clearly a trust boundary there. Or any system that you connect to the internet, there's a trust boundary on that line where you connect to the internet because there's a whole bunch of horrible, bad, damaging things that exist on the internet. So once we've got that high level kind of picture, and I find pictures do work really well here. Maybe it's me, I'm a very visual person, so having an actual diagram of a system is really, really useful. So having had that, we then start to look at each of the interfaces across a trust boundary and use a formal methodology to explore some of the potential threats there. For folks that are getting started with threat modeling, the STRIDE methodology is quite a good one. This is a methodology developed by Microsoft, and STRIDE is an acronym, and it basically calls out the factors that you should ask yourself about the flow of data across a trust boundary. The S stands for spoofing. Is it possible to make one side believe that it's talking to the other side, but actually it's someone bad? So can you pretend to be part of one side of that conversation? The T stands for tampering. Is it possible for a bad actor to modify information as it transits across that trust boundary? The R stands for repudiation, which is around, is it possible to state with certainty that a particular action did or did not take place? So a good example here is around financial transactions, where that transaction is occurring across a trust boundary. Can you prove that it definitely did or did not take place? I stands for integrity. Is it possible to modify information inside a data store? And again, usually if one side of an interface is writing to the other side of an interface, you could tamper with data in that way. The D is denial of service. So is there a method for preventing access to one side of that trust boundary? So a classic example here would be, how do we prevent, or rather, there is a risk that there's some bad actors on the internet that might flood our internet connection with a load of junk traffic, so our service is no longer usable. And finally, E stands for elevation of privilege. So is it possible across that trust boundary to make one side promote its access to a higher level than it should otherwise have access to, which would then potentially allow an attacker to access other information or modify other parts of the system. So that STRIDE framework just gives a few ideas for the participants in a threat modeling exercise to think about in a structured way, rather than necessarily going with gut feel, which, as we spoke about with the aeroplane versus driving risk example, isn't always reality.
Yeah, that's really interesting. So I'm trying to get an image of how this works. In a large organization, there are jurisdiction boundaries, which means ML DevOps is quite interesting actually, because it's a meta vehicle. It's something that it doesn't really have anything tangible. It might be a bunch of infrastructure as code scripts, so you can create these environments. It's like the recipe, right? But actually, there's the actual system that you create. So those are all of the downstream projects. And then all of those projects will talk to many of the other systems in the company, like, the data platform and various other platforms. So from a jurisdiction point of view, my virtual team, my data, ML, let's say my ML DevOps team only has access to the templates. So what do we do? Do we draw out an information architecture, and the nodes in that architecture are people and systems, and there's a jurisdiction boundary which represents what we can control, and then all of the interfaces between those things, those are the trust boundaries.
So that's a great way of starting from that 50,000-foot view in terms of what do you have control over in your system versus what are all those other external interfaces that you have to communicate with. And when I say external there, some of those may be effectively internal to an organization, but they're external to your specific team. So like I said, that's a great way of starting with a threat model exercise. In reality, there's going to be other trust boundaries within the system that you are developing. And so once you feel like maybe you've got a good handle on the threats that are to interfaces outside of your control, you may then want to zoom in to certain areas of your system and then kind of repeat that activity again in order to get full coverage at all levels.
Okay, fantastic. And when you do these exercises, what are the number one things that come up?
I wouldn't say that there's like a list of 5 things that always come up, because it really depends a lot on individual systems. I think in a lot of cases, you can see just basically, we aren't maybe encrypting a connection, or what authentication do we have on either side of a trust boundary. I guess on that one in particular, it's quite interesting. A lot of people understand that when you are communicating with a system that you are not in control of, you need to authenticate that connection in some way, shape, or form. But you also need to think about whether that is one-way authentication or two-way authentication. And a lot of people will automatically think about, say, a user spoofing an identity to their service. But what about the other way around? Can an attacker create a service that is spoofing something that a genuine user would interact with? So, and that's where that structure of threat modeling can really help, because it forces you to ask the question from multiple different angles, and even on directions which you wouldn't normally think about.
Yeah, it's fascinating. I suppose I'm trying to come up with a principled way to give people actionable advice, and the reality is it's very complicated, because if you did draw that map out and then you do a threat modeling exercise, it's so overwhelming that in a way you're just randomly sampling from the various different threats, and if you did the threat modeling exercise 5 times, you might get slightly different results. Maybe you'd get some overlap, but there's also something to be said for guiding principles when you architect these systems. I mean, I've been around the sun quite a few times, and I know to have isolation between environments, and minimum kind of privilege. And for example, on the cloud providers, they have VNet service endpoints, and we can reduce our attack surface by not having anything publicly available and stuff like that. So there's a certain amount you can do. But what I'm getting from this conversation, though, is that ultimately there are so many different kind of backdoors into your castle, and all of them could become a kind of vector of attack at some point later on.
Yeah, it is a huge problem space, and I guess it keeps us security folks employed. And the more complicated a system gets, the more components there are in a system, the more chance there is for there to be a flaw in one of those components. Yeah. And whilst there's a number of activities that can help discover those flaws, such as undertaking code reviews or automated code scanning, or doing application assessments or penetration testing, yeah, these are all good things that form part of an overall security assurance for a system. And threat modeling is just another one of those tools in the toolbox to help identify where there might be flaws. I mean, you mentioned things like adopting architectural standards or best practice. Absolutely, yeah. Making sure that a development team is aware of, say, the OWASP top 10 for web application security vulnerabilities. Really, really important, because you would like your developers not to code the vulnerabilities in the first place rather than discovering them later. So yeah, absolutely use all those resources. And if you have used all those good resources and you've got really switched on security-minded developers, then when it comes to do threat modeling, you're probably going to be left scratching your heads because you feel like you've covered everything off. But again, that structured methodology that comes with threat modeling really helps to tease out some of those items that you may not have thought about already.
Yeah, it's fascinating, and as you say, it's a multi-layered approach. It's like a huge sandwich, and many of the things can even be automated. As you're saying, you can do things like linting and the unit tests and the code scanning, and there are some principles, I think, around minimizing the chance of data egress or malicious code execution, and standardizing on the images you use if when you're running code in containers and so on. But as you point out, it's actually it's very kind of multifactorial, and there are so many different perspectives on this.
Absolutely. And each of these different tools in the toolbox serve a different purpose. You can't just say, oh, well, I can't be bothered to do code scanning or threat modeling. I'm just going to pay a penetration tester to have a go at my app and see whether they find something. Each tool does a different thing. Likewise, code scanning, it will tell you whether you have, say, I don't know, a SQL injection vulnerability in your code, but it won't tell you if you have a fundamental flaw in your business logic. You can have effectively secure code, but actually the application is still inherently insecure because, I don't know, maybe it allows an unauthorized person to see information that they shouldn't just by changing one value somewhere. And again, threat modeling, one of the key pieces that helps with is identifying where there's flaws in an overall architecture or design, because it encourages that qualitative conversation amongst developers rather than, I guess, the push button activity of a code scan or an application assessment.
Absolutely. And one of the things that we're getting to as well is I'm a big believer that many eyes make shallow holes. And what you're talking about is diversity, because one person might say, oh, we don't need security people. Why don't we just have developers that can code securely in the first place? And it's not as simple as that. You need to have different perspectives. And that's part of what the threat modeling exercise can do. But one thing that does worry me about centralized security is it can just become overwhelming, because you folks see so many different exploits. Behind the scenes, you're almost like compiling a list of best practices and guidance, and that list is probably longer in length than the Bible. So then you need to create a level of abstraction to hide away some of that complexity from my perspective, because it can become so overwhelming that I'll be discouraged from even interfacing with security. So how do you kind of deal with that information overload?
So I think, as you say, hiding a lot of the low-level detail off the bat is quite helpful. So, for example, I won't tell you about the 50 different ways that maybe an attacker might be able to establish persistence on a machine that they've just compromised, because there's no value in you necessarily knowing that. However, there's maybe a handful of things that can be done from a design or architecture point of view that help either make it less likely or less damaging if one of those things were to happen. And so, absolutely, by abstracting a lot of that away, it then makes a developer's job a lot easier. And that's why we say things like, well, encrypt information if you're transferring it across the internet. That's really simple, nice and easy. And maybe we might also say, oh, and make sure you use TLS version 1.2 or 1.3. You don't need to know what TLS 1.2 or 1.3 really means and the differences and the protocol versions. You just need to know, hey, I need to use that one because if I don't do that, then my information is at risk. And I don't need to tell you all the details about the different types of attacks on different versions of SSL and different ways of downgrading connections and all this kind of complexity that an attacker might use. You just need to know, hey, I need to do X and Y, and I should be good on 95% of the cases around this particular area.
Amazing. Well, Andy, it's been such a pleasure talking with you. By the way, folks, so Andy has an amazing YouTube channel all about cybersecurity, and he's actually working on an entire series around AI security coming up.
Thanks for the plug there, Tim. Yeah, so most of the content I create is quite technical in nature, exploring some of the techniques and tactics that attackers use to compromise systems. But yeah, as you say, yeah, got a little project on the go in the background looking at some more AI security related threats. It may be a month or two before that starts to reach the eyes of the audience. But yeah, do get subscribed if you want to see that as soon as it starts coming out.
Absolutely. Make sure you subscribe. I've learned so much actually from watching Andy's YouTube channel.
Hi, I'm Andy and welcome to my little corner of YouTube. I create cybersecurity videos designed to help develop intermediate level skills. My main series, Attack, Detect, Defend, demonstrates the variety of techniques used by hackers and what can be done to detect and prevent attacks. I've published video walkthroughs of a few capture the flag competitions, and I have a few other cool projects in the works coming soon. If all this sounds right up your street, take a browse at a few videos and consider subscribing.